Hello students. So in my previous video I have already discussed about pure substances and also about the impure substances, that is the mixture. So in today's part we'll discuss about the solutions, then different types of solutions, and also we'll know about the suspension, then colloidal solution, and also some methods of separation of the components of the mixture. So let's know about it. So now let us know first about the solutions. So solution, it is what? It is the homogeneous mixture of two or more substances. So example is the lemonade, then soda water. So you see in the lemonade, what things are added? There lemon juice is there, water is there, salt is there, sugar is there. So that is what? There more than one substance is there, more than one substance. So that is known as the solution. So in the solution, it has two components. The one that is the solvent, then the another one, it is the solute. So you see, the solvent, it is the component of the solution that dissolve the other component in it. So example is water, alcohol. So you see the water. The water, it has the capacity to dissolve the other substances, that is the sugar, salt, right? But solute is what? It is the component of the solution that is dissolved in the solvent. So that is known as solute. So the sugar, then the salt, it is the solute. Okay. Now let us know about the properties of solution. So solution, it is a homogeneous mixture. Then the particles of the solution cannot be even seen with a microscope. Then the particle size of the solution, it is less than 1 nanometer in diameter. Then the solution, it is stable, and true solution, it does not scatter the light, and the solute particles, it cannot be separated from the mixture by the process of filtration. So these are the different properties of the solution. Now let us know the different types of solution. So you see, they define criteria on what on that basis only the types also it is there. So you see the first one, on the basis of water as a solvent, okay, or on the basis of whether the solvent it is water or not. So solution, it is of two types. So the first one is the aqueous solution, and the second one is the non-aqueous solution. So in aqueous solution, the solution, these solutions, they have the water. Okay, example, sugar in water, then carbon dioxide in water. Then non-aqueous solutions, what? The solutions, they have the solvent but it is not the water, they are the other things, that is the benzene, petrol, then carbon tetrachloride. So that things, they act as a solvent but not the water. So example is the sulfur in carbon disulfide and naphthalene in benzene. So you see, on the basis of water as a solvent, there are two types. One is the aqueous solution and another one is the non-aqueous solution. So aqueous solution, remember that these solutions have the water, but in non-aqueous solutions, the solutions, they don't have the water, but the solvent in there, it could be either the benzene, petrol, they act as the solvent in that. So you could see here, these are some aqueous and non-aqueous solutions. Next, on the basis of the amount of the solute added, it can be classified into three types. So the first one is the unsaturated solution, the second, it is saturated solution, and the third one is the supersaturated solution. So in unsaturated solution, you see where more amount of solute can be dissolved in a solution at a given temperature. So suppose in the hot cup of coffee, we can keep on adding the spoonful of sugar. So that is the unsaturated solution, where we can keep on adding more and more solute in them. Then the second one is the saturated solution, where no more solute can be dissolved in the solution at a given temperature. So that is the soda. So in the soda, we cannot add any more solute. Then the third one is the supersaturated solution. So the supersaturated solution is what? Is the one where the solute is, that the solute, it is present in excess amount and they are dissolved in the solution forcefully by raising the temperature. And here the excess solute particles, they are later on they are found in the form of crystals by the process of crystallization. So the example is the sodium acetate. So here we got, on the basis of the amount of solute added, we got three types. One is the unsaturated solution, where more amount of solute it can be keep on adding. in the solution at a given temperature, then saturated solution where no more solute can be dissolved in a solution at a given temperature, and supersaturated solution where the solute it is present in excess amount and it is dissolved in the solution forcefully by raising the temperature, and which the solute particles later on it can be found in the form of crystals by the process of crystallization. Next, on the basis of the amount of solvent added, it is of two types. So the first one is the concentrated solution. So concentrated solution has large amount of solute in the given solvent. The example, it is the brine solution, and the dilute solutions what it has a small amount of solute in a large amount of solvent, that is the salt solution. So you see, on the basis of the amount of the solvent added, the two types of solution is what? One is the concentrated solution and another one is the dilute solution. So these are the different types of the solution. Now let's know about what is solubility. So solubility means what? It is the amount of solute present in the saturated solution at a given temperature. So that is known as the solubility. And let us know what is concentration of the solution. So the concentration of the solution, it is the amount of solute present in a given amount of solution. Okay, and there are two methods of finding the concentration of the solution. The one is the mass by mass percentage of the solution, and next is the mass by volume percentage of the solution. Now let us know about the suspension. So suspension is what? It is the suspension, it is the heterogeneous mixture where the solid particles did not dissolve but it remains suspended in the bulk of the medium. So you see the chalk in the water. So the chalk here, it is the solid particles and it do not get dissolved in the water, but the chalk particles it remains suspended in the bulk of the medium. So that is known as the suspension. So there are different properties of the suspension. So suspension, it is a heterogeneous mixture, and then the particles of suspension it is visible through our naked eye. Then the size of the particles is this greater than 100 nanometer. Then it is unstable mixture. Then here the solutes is settled down at the bottom over a period of time, and it scatters light when light is passed through the solution. So this is the properties of the solution of the suspension. Next, it is the colloidal solution. So colloidal solution is what? It is also a heterogeneous mixture, and here the size of the particles it lies between the true solution and suspension. And here the colloidal particles can easily scatter a beam of light, and that phenomenon is known as the Tyndall effect. And this colloidal solution it has two components, remember, that is one is the dispersed phase and another one is the dispersed medium. So you could see here in the picture these are some colloidal solution. Now let us know the particles, means the properties of the colloidal solution. So here the particles of the colloid it cannot be seen by naked eye individually. So you see in the blood, can we see the particles? No, it cannot be seen. So then next it is the heterogeneous, it is a heterogeneous mixture, and thus the solute and solvent cannot be separated by filter paper. Then next the size of the particle is smaller than suspension but it is greater than solution, and it is a stable mixture. So now let us know about the physical change and also about the chemical change. So what is the physical change and what is known as the chemical change? So in physical change, remember, here it is all about the change of the size, shape, then appearance of the substance. But in chemical change it brings the change in the chemical properties of substance. So suppose in physical change, you see, we can take in the example of the ice cubes. Okay, the ice cubes in a tray. Okay, that ice cubes, square ice cube, it can be changed into water, and that water it can again be changed into ice cubes. So you see that is the physical change where there is no change in the chemical composition of the substance, no new substance is formed, and the change it is temporary. So whatever if the ice cube it changed into water, but that water again it can be changed into ice cube. So the change it is temporary and it is reversible. But in case of the chemical change, you see, if we take the example of the milk, if you keep for some days it change into curd, so that curd it cannot be changed into again milk. So that is known as the chemical change, where there's always the change in the chemical composition of substance, and where the new substance is always formed, and the change is permanent and it is irreversible, it cannot be reversed. So this is known as the chemical change. So now let us know about the different methods of the separation of the components of the mixtures. So what are the different methods? So the first one is the evaporation, that is very common and everyone knows about it. So it is what? It is the process where the it is used to separate the solid substance that is dissolved in the liquid, and it is based on the fact that the liquid vaporizes easily and the solid it do not. Suppose you see, if you take in a beaker, okay, salt solution, and we are heating it. So when we apply the heat, the water it get evaporates, and then what it remains? The salt. So that process is known as the evaporation, and this evaporation process it is mostly used for obtaining the salt from the seawater. Next you see, it is centrifugation technique, and it is the method of separating suspended particles of a substance from a liquid, in which the mixture it is rotated at a high speed in a centrifuge. So that is the centrifugation method. So you could say, so this device is used in the centrifugation technique, and the application is mostly it is used in the dairies to separate the cream from the milk, and also it is used in the washing machine to squeeze out the water of the wet cloths. And here you see this centrifugation machine, it has a one main principle. You see, when the mixture is rotated very fast, the denser particles it is forced to go to the bottom of the centrifuge, and the lighter particles it stay at the top. So that is the main principle of the centrifugation method. Next one, it is the separating funnel, and this is one of the very simplest technique where it is used to separate the mixture of the two immiscible liquid like oil and water. And here this separating funnel it is also used, one we got it that to separate the mixture of oil and water, then also in the extraction of iron from its ore, where the lighter slag it is removed from the top, and to leave the molten iron at the bottom of the blast furnace. So that is where this separating funnel is used. And here separating funnel is also have one principle, that is what, when a mixture of two immiscible liquid it is kept in the separating funnel, here the liquids is separate out in layers depending on the densities, okay, densities with heavier forming the top layer. So you see here in the picture, the oil is what? It is the olive oil, and it is mixed with the water. So olive oil it cannot be mixed with water, okay. So here the liquid is separate out in layers, okay, that is depending on the density. So olive oil the density is more, so it is heavier, so it will always form the top layer. So this is one of the main principle of this using the separating funnel. Next is the sublimation method, and the sublimation method it is used to separate the components of mixture which can sublime on heating, okay. And this application it is mostly where one, that is the common salt, it can be separated from the mixture of the salt and ammonium chloride, and this method it can be also used for iron that can be separated from the mixture of iron fillings and camphor. So this sublimation technique is used. Then next is the chromatography. So this method it is used to separate two or more dissolved solute which are present in the solution and in very small quantities. And this chromatography technique, okay, it is used to separate colors in a dye and also to separate the drugs, okay, from the blood. So this technique it is used, and this chromatography technique it is based on the fact that though two substances is dissolved in the same solvent, but the solubilities can be different, and the components which is more soluble it rises faster and it gets separated from the mixture. So this is the principle of the chromatography. Next, it is the method, it is the distillation, and this method it is used to separate the mixture of solute in liquid, and it's the process, this is the process of heating the liquid to from the vapor and then cooling the vapor to back into liquid. And it is used, this distillation method is used for the separation of the components of mixture which is contains the two miscible liquids that is boiled without decomposition and have sufficient difference in the boiling point. So you see this, it is mostly applied to remove the salt from the seawater to obtain the drinking water. This distillation method is used. You see this is the apertures of the distillation method, and this has one important principle, that's the volatile liquid, it evaporates on heating and which can be recovered by cooling its vapors by the process of condensation. So this is the main principle of this distillation technique. Next, it is the fractional distillation, and in fractional distillation it is the process of separating two or more miscible liquids by the distillation, and here the distillate is being collected in the fraction due to the boiling at different temperatures. And this fractional distillation it is mostly used to separate the mixture of miscible liquids, and it is used to separate the crude oil, that is the petroleum, into useful fractions like kerosene, petrol and diesel. And this fractional distillation it is based on the principle that in a mixture of two or more miscible liquids, the separation of various liquid it depends on the boiling point, and here the liquid has lower boiling point and it boils fast and can be obtained first from the fractionating column, and then the liquid have the higher boiling point. So this is the principle of the fractional distillation. And the last method is the crystallization method, that is the process which is used to separate the pure solid in the form of crystals from the solution. And here this method it is mostly applied to obtain the crystals of the alum, that is known as Fitzgerald, from the impure samples, and also to obtain the pure copper sulfate from an impure sample. So this is all about the different methods of separation of the components of the mixture.